AusNet Services is a different organization. It is an utility which is owning and maintaining the power transmission and distribution network. Now, so what I'll be talking to you is the application of the science, or it's more on technology, it's applied research. Where I come from is actually my role has been in innovation and research. That means we try to find out new ways of doing the things. For example, how to maintain the safety and reliability and the cost efficiencies of the physical infrastructure which we maintain for substations and transmission and distribution lines, which you see outside. The one which I'm presenting to you today is on energy storage. And this is the one which I have worked with the Center of Excellence in Electrochemistry in Deakin University. Look, there is an expensive physical infrastructure, the network. And in the summer, 40-degree day, that network struggles to supply the required load. So that demand is there only for 3-4 days in a year. So the one option, traditional option, is to augment the network, to actually upgrade the lines, poles and wires, upgrade the transformer, spend millions of dollars. For what? For assets which are used only five days in a year. So utilization is so poor. And that is the driver, and saying, can we manage this peak demand in some other way, in more innovative way? So there are many programs to manage the peak demand are happening, and the storage is one of the mix. So the storage is the one which we have trialed at Thomastown, that we have put 1 megawatt lithium-ion battery, which actually we charge in the night time, and during the daytime, when the network is struggling, it will actually supply. So it will work with the grid and it will supply the power. And it can also work in an isolation mode, where if there is a problem with the grid, it can still supply the customers like in an island mode, so on its own. And in doing this project, because this was Australia's first of its kind, means I'm not saying the batteries are new, I'm not saying the storage has not been discussed. What I'm saying is the application of this size of megawatt size battery, 1 megawatt hour battery, to support the grid and to work with the grid and work on grid and off grid things, so it can synchronize with the grid, it can work with the grid, it can go off the grid, and people don't even realize it is all bumpless transition. So this was the thing, and I actually contacted, I think initially I contacted Professor Douglas McFarlane, and I said, during the tendering process, I said, look, I'm not a chemist, so I don't know electrochemistry. So how do I select the right battery? Because there are performance issues, there are fire issues, there are safety, other safety issues, there are life issues, and in lithium-ion there are so many chemistries. So finally he put me to Dr. Patrick Hollett, and we actually took his advice on, there was different kind of batteries offered during the tendering process. And so in fact, Deakin sort of evaluated us, the chemistry of the batteries in terms of the criteria which we wanted to select the right battery for that, and to have the safety, to guarantee the safety, and to have the performance what we wanted. So this system is now working. It is operational. Hopefully the summer is likely to be a good summer this time. So we'll collect the data, how it performs.